This video is about approximating area under a curve using Riemann sums and the trapezoid rule. The first way to find an area under a curve is using Riemann sums. Riemann sums are used to approximate the area under a curve, and it's often represented using an integral. There are three kinds of Riemann sums. There's a left Riemann sum, a middle Riemann sum, and a right Riemann sum. In order to find the area under a curve, using Riemann sums, we make rectangles under the curve in order to estimate this area. So if we take left rem for an example, we're trying to make rectangles under the curve in order to approximate the area. And since it's a left rem, we're going to start by making our boxes from the left. So we're doing increments of 1 on the x-axis. So you start on the left, and once it hits the curve, that's where you make your box. So this one, it starts at 0 on the left, so we draw the line all the way across to the 1 spot. And now we have to make our second rectangle, so we go straight up from here until we hit the curve and draw our box over till we hit the next point on the x-axis. For the third box, we go all the way up again until we hit the curve and then make the box like this. As you can see, the left rem is an underestimate of the actual area. So if a question were to ask you to do a left Riemann sum and ask if it was an overestimate or an underestimate, it would be an underestimate. There's also a middle rem, and so with this one you go halfway between the points that you're ending on, and then until it hits that curve, and you extend the line out each way, so like that. And then for the second one, you go halfway up until it reaches the point at the graph, and then draw your box like this. And then same thing for the last one, you go to the middle, go all the way up until it hits the curve, and then draw in the box. This one is the closest estimate because there's some under here that you're missing, but there's also some over, so it's pretty close to the real estimate. If you're doing a right rem, so you start at 0 and you go all the way to the right and go up until you hit the curve, and then draw your box in, and then go to the next box, you go all the way over up until you hit the curve and draw your box. For this one, this last one, you'd still go all the way over, but on this graph it doesn't reach that far, but it would be somewhere up here till you hit the graph, and then you would draw your box in this way. And if the question asks if a right rem is an overestimate or an underestimate, it would be an overestimate because you have all this excess that's above the line. So now in order to approximate the area under the curve, you find the area of each of these boxes, which we know is length times width, so we would just take the length down here times the height or the width or whatever, and that's the area of this one box, and you'd take the area of this box by doing the length and the height and finding that area, and then you just add them all together. Same for the middle rem and the right rem. Alright, for this example, we will be doing a midpoint Riemann sum with 4 subdivisions of equal length in order to approximate the area under the curve from 0 to 16. And they give us a chart over here from time 0 to 16. So when it asks us to do 4 subintervals of equal length, we're going to be taking this chart and dividing it by 4 in order to find our subintervals. So first we'd be going from 0 to 4 for one of our intervals, and then from 4 to 8, 8 to 12, and then 12 to 16. And so that's going to be our 4 subintervals if we were to graph this. And since it's asking for a midpoint Riemann sum, we're going to want to take the midpoint of each of those subintervals. So the midpoint from 0 to 4 is 2, the midpoint from 4 to 8 is going to be 6, and then the midpoint from 8 to 12 is 10, and from 12 to 16 is 14. So before we start calculating the area of these rectangles, I find it easier to draw a graph first so I can visually see where these rectangles are and what values I need to be plugging into this equation. So I'm going to make a graph like this, and then I'm going to fill in the x-axis and the y-axis. So I labeled the x and y-axis, and I plotted the points and made like the curve that we're going to try and solve for the area underneath it. So for these rectangles, it's going to be an M rem, so we need to go from the midpoint of each interval and then take that up until it hits the curve and then draw our rectangle. So in between 0 and 4, the midpoint is 2, so at 2 we're going to go up until it hits the curve and then draw in the box from there. And then next we have from 4 to 8, and the midpoint here is going to be 6. So we go from 6, draw our line up, and then complete the rectangle there. And from 8 to 12, our midpoint is 10, so we go draw our rectangle. And then from 12 to 16, it's 14. Draw the last rectangle in like that. And I see that that point is not on 16 on the x-axis, but pretend it is. So now we just need to find the area of each of these boxes and add them up. Now to get the area of these rectangles, we need to take the height of the rectangle by the length, and we get the height from the height of the curve at this point. So for this first rectangle, our x is going to be 2, and so to find our height for this rectangle, we go up until it hits the curve. So our height is going to be the y value at x equals 2, which is 16.3. So it's 16.3 times the x value. Don't get confused here. Your x value is going to be 4 since it goes from 0 to 4. So you're going to multiply 16.3 times 4 for this first box, and that's the area of the first box. And then for the second box, you do the same thing. So you take 6, go up until you hit the curve, and at 6, your y value is going to be 17.1. And then you don't forget the x equaling 4. So put that in there, and that's your second box. And you keep doing this until you've added up all 4 boxes. And then you type that into your calculator, or if you have regular numbers that are easy to multiply, you do it in your head if it's no calculator. And this should be an approximation sign. Your area should come out to 264.4, and that is your answer. Next is the trapezoid rule. There is a formula for this, but it's much easier to just memorize the area of a trapezoid and then add all of them up together like we did with the Riemann sum, instead of following the actual trapezoid rule formula. So in order to approximate the area under the curve, using the trapezoid rule, you find the area of each trapezoid and then add them together. Up here I have the area of a trapezoid, which is 1/2 times h times base 1 plus base 2. When finding the area of a trapezoid, make sure not to confuse which are your bases and which are your heights. So the x-axis is going to be your height, because the shapes match here. So your h is going to be at the bottom, and you're going to have b1 and b2 on the sides. And you use those numbers, plug them into the formula, and that's your area for a trapezoid. And then once you have all of those trapezoid areas, you just add them together. For this example, we're trying to find the area under the curve from x equals 0 to x equals 4 using 4 subintervals while using the trapezoid rule. I've already put up a graph and drawn in the trapezoids, but we still need to find the area of each trapezoid and then add them together for the final area. So for the first trapezoid, we have to remember the equation for area of a trapezoid, which is 1/2 times h times b1 plus b2. So for this first trapezoid, our height is always on the bottom, and in this case it's 1. So we write in the 1/2 times 1, and b1 plus b2. So this side's going to be b1, and this is going to be b2. b1 is going to be 1, and then b2 is going to be 2. And for the next trapezoid, we do the same thing. So I write 1/2 times 1 again, and then the first base here is going to be 2, and then base 2 is going to be 5. And you keep doing this until you've calculated the last area for the last trapezoid. And once you have all of those calculated, you add them up in your calculator, and you should get an answer of about 26. And that is your final answer.